Hello, everyone. My name is Krija Mendoza, and along with my partner, Michelle Mislang, we are presenting to you our project entitled Determination of the Effect of Sugar Concentration in Strawberry Preservation. So, first things first, what is preservation? Preservation is the technique used to prolong the shelf life of the food product. Different methods are used in preserving varieties of fruit and vegetables, and these are the following methods. First is dehydration, thermal processes. It can be chemical preservation, irradiation, and freezing. So in this experiment, we use strawberry as the product, which has a low level of pectin, and chemical preservation was the method performed to test the efficacy of each different sugar concentration. Why strawberries? Strawberries are one of the most nutritious and delicious fruits. They contain powerful antioxidants that help prevent numerous diseases such as cancer. Strawberries are also high in fiber and an excellent source of vitamin C, folate, and potassium. They are also one of the most used fruits for preservation. Like any other fruit, they are perishable and susceptible to mechanical damage or infection by fungi, bacteria, or viruses. As a result, it often loses its specific original properties such as texture, aroma, taste, appearance, and nutrients. Traditional jams are usually done by boiling the crushed fruit and sugar. Strawberries are known to have low pectin. Pectin is a substance that is naturally found in fruits and is needed to form a fruit-based gel. Adding pectin requires less cooking, which helps preserve the natural fruit flavors. Citric acid helps in the inhibition of the thermophilic bacteria by acidulation, and then most fruits are preserved by high sugar content. Sugar acts as a preservative by osmosis, so it attracts all the water, which causes microorganisms or flora to be dehydrated as well. That stops them to multiply, and it also helps the gel formation. So, what is the purpose of this experiment? In this experiment, we tested if we could preserve the strawberries in various components such as sugar, pectin, and citric acid. So the objective was to determine the lowest concentration to which the strawberry can be preserved. So in this experiment, we had two trials, trials one and two, which included a negative control and three positive controls. So we had three ratio, 50 to 50 ratio, 45 to 55 ratio, and 40-60 ratio. So for the materials and methods of this experiment, we used strawberries, sugar, pectin, citric acid, wide bottom skillet, water, sterilized jars with lid. So for the trial one, we needed to prepare three positive controls and one negative control. So for the positive control, we had a 50-50 ratio. So we used 454 grams of washed strawberries, 454 grams of sugar, 2.7 grams of pectin, 2.5 grams of citric acid. For the 45-55 ratio, we use a 454 grams of washed strawberries as well, 554 grams of sugar, 114 ml of water, 2.9 grams of pectin, 2.7 grams of citric acid. For the 40-60 ratio, we used 454 grams of washed strawberries, 681 grams of sugar, 150 ml of water, and then 3.8 grams of pectin, 3.6 grams of citric acid. And then for the negative control, we prepared 454 grams of unwashed strawberries and 454 grams of sugar only. So before the treatment, we took note of the physical properties of the strawberries, such as the shape, color, and size. We recorded the pH and taste as well. So before everything, we prepared by sterilizing the jars, and we done that by submerging them in boiling water for at least 10 minutes. and then let them cool down in a clean towel, as well for the lids as well. So in a wide bottom skillet, we start by pouring down the sugar, the water, and the strawberries for the positive controls if they have water, and then for each ratio, and then we bring it to boil. And then we simmer for 2 minutes, and then we add the needed pectin powder and mix. And then after that, we let it simmer again, and then we add the citric acid, and then let it simmer, and then remove the froth. Then we transfer it to the clean sterilized jars, and then we check the pH after treatment and took note of the physical properties. Store it in a cool, clean, dry, dark place, not exceeding 35 degrees Celsius. So for the next trial two, sorry. So for the trial two, we did the same as well. We had three positive controls and one negative control. So we so for this one, we used a lesser amount of strawberries just to save money as well, because we all know that we are going through a pandemic. So we tried our best to perform the experiment in a way that is accurate but is efficient as well. So for the 50-50 ratio, we prepared 200 grams of washed strawberries, 200 grams of sugar, 1.2 grams of pectin, and 1.2 grams of citric acid. So for the 45-55 ratio, we prepared 200 grams of washed strawberries, 244 grams of sugar, 50 ml of water, 1.3 grams of pectin, and 1.2 grams of citric acid. So for the 40-60 ratio, we prepared 200 grams of washed strawberries, 300 grams of sugar, 66 ml of water, 1.7 grams of pectin, 1.6 grams of citric acid. So for the negative control, we prepared 200 grams of unwashed strawberries and 200 grams of sugar. So the same as well. So before treatment, we took note of the physical properties of the strawberries, such as the shape, color, and size. We recorded the pH and the taste as well. And then we started everything by sterilizing the jars first and the lids by boiling them in water for 10 minutes. And then we cool them down in a clean towel. And then we start everything by heating a wide bottom skillet, and then we pour in the sugar, the needed water, if ever, and then the strawberries for each ratio. And then we bring it to boil. We simmer it for 2 minutes. We add the pectin powder, and we mix. We add the citric acid, and then we remove the froth. Then we transfer everything, each trial or each ratio, to a clean sterilized jar. We checked the pH after the treatment, and we took note of the physical properties as well. And then we stored them in a cool, clean, dry, dark place, not exceeding 35 degrees Celsius. So I'm gonna pass it on to my partner, who will be discussing the results for the data collected from trial one, trial two, and the conclusion as well.
Hi, I'm Michelle Miss Lang, and I'll be discussing the second part, which is the results and the conclusion of our experiment. So in trial 1, the measurement used is 454 grams of Del Fresco Yes Berries, that is the brand from Walmart, while the texture star pectin, red path white sugar, and Maillard citric acid varies depending on the concentration ratios of each positive control. The pH was tested before and after each treatment, and both member 1 and member 2 had a result of an average of 4 for the negative control and the 50-50, 45-55 positive controls, and an average pH of 3.5 for the 40-60 positive control, which indicates high acidity in the fruit product. And then proper preparation and storage contributed with the presence of no mold growth or any signs of spoilage. The consistency, color, smell, and taste recorded are the same when compared to the day 0 of the trial 1. So we tested the pH from day 0 and day 14, so after 2 weeks, and we got the same result, which is pH of 4. So as you can see in the picture, the left and the middle are for the member 1 result, and on the right side is for the member 2. So let's move on for the results of trial 2 experiment. So in trial 2, we have reduced the measurement, which is 200 grams of the fruit product, because in trial 1, we have used 454 grams. And for the member 1, she used the same brand, which is the Del Fresco Yes Berries brand. And for the member 2, it was the Berry Boss brand. Each ratio concentration of positive control and the negative control has resulted in an average pH of 4 for both members. And the water content differs is directly proportional for each ratio. The more distilled water added, the more preserved jam was produced. The consistency, color, taste, and smell recorded from the day 0 are identical with the day 14. Moreover, no formation of microbial growth was recorded throughout the experiment. So on the left is the member 1 product, and on the right side is the member 2 product. So for our conclusion, all strawberry jam produced, regardless of the sugar concentration and water content, resulted in a formation of no microbial growth. So therefore, our hypothesis is rejected or not accepted, because we have stated there that the 60% sugar concentration will produce a more effective in preserving the fruit product. But regardless of the sugar concentration, all of the ratios produce a no microbial growth. Probably this is true because of the pectin, which is the preservative ingredient that helps the preservation to be successful.